Hey, MathCook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathCook it up. Hey Kooks, this question says, use inverse matrix to solve the system of equations. Okay, so we have two equations here with two variables. Let's take a look at the steps to solve for a system of equations using an inverse matrix. So step number one is we're going to find the inverse, A inverse, of the coefficient matrix A. And step number two is we're going to multiply the inverse matrix here times the constant matrix to get our answer. So here's kind of what we're going to set up eventually in this problem. So x represents the variables that you're solving for. In this case, it's x and y. And that's going to equal the inverse of the coefficient matrix, A inverse here, times B, which is the constant matrix. So what is the coefficient matrix? Well, let's go down here and look at an example. The coefficient matrix for this particular system of equations would be just the coefficients of the variables here. So it's going to be a 2 by 2, and we're going to call it A. So it's 3, 2, and then negative 1, 1. So here is our coefficient matrix. Now the constant matrix, or B here, is just the two constants on the right here, so 10 and 8. So our constant matrix B is 10, 8. All right, so let's go ahead and apply these steps to our equations here. So I'm going to erase our chart here, and then we will continue to find our coefficient matrix and our constant matrix. So our coefficient matrix is going to be 1, negative 2, 2, and negative 3. So I'll go ahead and write that here. 1, negative 2, 2, and negative 3. The constant matrix is 5, 10. So that one's pretty simple. All right, first we're going to find, number one was to find the inverse matrix of our coefficient matrix, so A inverse. So let's go ahead and bring down our equation for that. So here's the equation to find A inverse. So if matrix A is A, B, C, D, what you do is you find the determinant, which is AD minus BC. You put that underneath 1, and then you times that fraction by, and you switch A and D. So A and D are originally here. Now it's here, DA. And then you negate B and C. So you do the opposite signs of B and C. But notice B and C stay in their original positions. They're just opposite of what they used to be. All right, so let's go ahead and apply that to this problem here. So I'll go ahead and write. So our A inverse is going to equal 1 over, and then AD minus BC. So it's going to be 1 times negative 3 minus, and then BC. So B is negative 2, and C is 2. All right, so there is our fraction out front. We switched D and A. So here's A, here's D. So now they switch. So now negative 3 will be in the front spot, and then 1 will be in the bottom right. And then we negate B and C. So this is negative 2, so now it'll be positive 2. And then this is positive 2, which will now become negative 2. All right. So we just simplify this. On the bottom here, we get negative 3. And then this ends up being positive 4, which is 1. So 1 over 1 is 1. So we have negative 3, 2, negative 2, 1. All right. And then the 1, when we distribute the 1 in here, we would normally distribute this number to all four of these numbers, but since it's 1, it just ends up being this matrix. So our inverse matrix for our coefficient matrix is negative 3, 2, negative 2, 1. So I'm going to write that down here on the right so we can save that information. And let's go ahead and erase our work we just did. And then now we will find the variables that we're looking for. So we have x equals A inverse times B. So we found A inverse right here. So let's go ahead and write those numbers in. So we have negative 3, 2, negative 2, and 1. All right, and then our constant matrix was 5, 10. So we're going to put that here for B. So 5, 10. Now, as a reminder, to multiply matrices, they must have the same inner value when you're looking at the dimensions. So let's find the dimensions for the first matrix. This is a 2 by 2. As a reminder, we do rows by columns. So there's 2 rows and then 2 columns. So this is a 2 by 2. And then the next one here is a 2 rows by 1 column. So it's a 2 by 1. And notice these guys are the same here. So that is a green light. We have the green light. That means we can multiply these matrices, and then we will eventually get a 2 by 1. The outer guy here is the resultant. So we're going to have a 2 by 1 as our answer. All right, so let's go ahead and multiply. So whenever you multiply matrices, you go right on the first one and then down on the second. So that's why I drew these red arrows here. So if we want the top left, we go top and then left. So I'll say that again, top left for this number. So top left, so we're going to -3 times 5. And we always move simultaneously. So -3 times 5, and then plus, and then we move to the right and then down. So 2 times 10. So 2 times 10. All right, now we want the bottom. So the bottom here, and then it's really just bottom, like there's not really left or right, it's just bottom and then the number. So we're going to go -2 times 5, and then plus, and we just keep moving. We move right and we move down. So 1 times 10. So you always have to move simultaneously when you're multiplying matrices. All right, now we just simplify. So we get -15 here plus 20, so that gives us 5. And then we have here -10 plus 10, which gives us 0. All right, and remember we were solving for x and y, so I'll put those variables right here. So this matrix is really xy. So that tells us that x equals 5 and y equals 0. So our final answer is 5, 0. So that's where these two lines intersect at 5, 0. And we used the method of inverse matrices to solve this system of equations. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.